Okay. Okay, so hello, hello everyone. So my name is Jean-Philippe Faure. I'm CEO at Progilon and chair of the IEEE 1901 working group and chair of the HD-PLC technology working group and standard task group. And you have my email address on the first page. So you can contact me. Do not hesitate to contact me afterwards if you have any questions. So today I will talk about the IEEE 1901 standards and start with the history of the standards. So the standards, the first version of the standards was approved in 2010. Then an amendment was developed and approved in 2019. And I will detail in my next slide all the different versions to let you understand the progress we made in the standard. In 2020, the original standard was revised to include Amendment A, and it was the main purpose of the revision. So I won't talk that much about this revision 2020. Then in 2021, another amendment, Amendment B, 1901B, was approved, and finally, last year we started a new project, P1901c, as Miyake-san introduced earlier. So I will talk about all these different projects and standards. So the first standards was approved again in 2010. The main focus was broadband over power line. So everything started from this. And two physical layers were standardized. One based on wavelet OFDM and the other one based on A50 OFDM. And the coexistence was also defined between the two physical layers. Now, if we focus on the wavelet OFDM, a single channel wavelength physical layer was defined. So it was operating below 31 megahertz, and the channel provided an average speed of a maximum speed of 240 megabits per second. So this was really when we start standardization, we focus on this specification. Next came 1901A, and the purpose of Amendment A was the addition of a flexible channel wavelet physical layer. So what is this? Flexible channel wavelet means that we introduce the concept of selectable channels. So we created 15 different selectable channels. The characteristic of each channel, it is that they have the same number of carriers, okay, in each channel. What is different from a channel to another channel is the carrier spacing and the offset. Carrier spacing ranges from 1/4, 1/2, 1 multiplied by 2 or multiplied by 4. Carrier spacing of 1 is a reference to the original standard 2010 with a single channel. The other carrier spacing either reduce the frequency band of a channel or extend the frequency band of a channel. The purpose of this was to provide channel for long distance communication, and it is the case when all carriers are concentrated in a small frequency band, so all the energy is already concentrated on a small band, but also provide some flexibility with channels for high-speed communication. In that case, the carrier spread over a large frequency band, and then you can have a higher speed, but the energy is spread and the communication range is shorter. The focus of 1901A was still broadband communication over power line, and we added also some communication, for example, on a coax cable for high-speed communication on coax cable. So here, this is an illustration of the different channels that are available in 1901A. So you see basically on top the channels for long distance, so the carrier spacing was reduced. All this thing is achieved by resampling. Resampling allows basically to have these small channels and also to define the offset. So you see X1, this is the original channel defined in the version 2010. And we added all the other channels, so either by reducing the carrier channel or the carrier spacing, sorry, or extending the carrier spacing. For the smallest channels are X4, 5, 6, and 7 on top. It provides 4 channels at a speed of maximum speed of 60 megabit per second. And the fastest speed is provided by the channel on the bottom, which is X12, which is one channel at 1 gigabit per second. And for instance, it can be used on coax lines. So the channel X2 allowed to transmit up to 125 megahertz, but actually there's a limit on power line. We cannot transmit above 100 megahertz. So then in 2021, we developed and approved another amendment, which is 1901b. And the purpose of this amendment was different. It was not about the PHY. It was about the addition of support of IEEE 822.1x port-based network access control. So basically improving authentication for the system. This need was identified in particular for the smart grid market, but on other application. And there's an illustration you can find on Wikipedia about how it works. So there's an authentication server that use a radius protocol with an authenticator. And when the supplicant wants to join the network, the supplicant asks the authenticator, and there's a check of the certificate on the authentication server. And then the supplicant is allowed or not allowed to join the network. So this standard is very popular in many deployments. So we thought it was very important for 1901 to support this. And the amendment 1901b explain how to do it and provide all the primitives and all the protocols needed to support this. Then the more recent project is P1901c. So this project is in development since May last year, so quite recent. And what it is about? So there are several objectives in this project. It will define an extended flexible channel wavelet physical layer. So basically, this is an extension of the flexible channel wavelet PHY defined in 1901A. And also, we want to extend the use of this physical layer to any media. So not only focusing on power line communication or coax, but also provide this technology for any media, including wireless. This is what we'll see in the next slide. So this is the first objective of the project. The second objective of the project is to support the IEEE 1588 precision time protocol. So this is also an important protocol which is used in the industry application to be able to control precisely the time. So we will add the necessary primitive at the PHY layer to support this protocol, and we'll explain exactly how to use this protocol with 1901. So all the purpose of this is to provide really for high speed and also low speed capabilities for Internet of Things communication devices. So again, the project started in May last year, and in October, the project acted a first baseline text. So progress is very good. I did not put any date about approval or expecting approval, but it's progressing very well. So let's talk more accurately now about the extended flexible channel wavelet physical layer. So this extended PHY will provide 2 new channels in low frequencies. So the purpose was really to address this part of the spectrum from DC to 15.6 megahertz. So it will, again, the same characteristic for same channel, each channel will use the same number of carriers as the previous one. And the way to achieve this is to introduce new carrier spacings. So to divide the carrier spacing by 8, 16, or 32 using resampling again. So how it will look like. So this is an illustration of about the new channels and the 1901A channels. So the channels in yellow are the 1901 channels. You could recognize some of them, ranging from DC to 15 megahertz. And with resampling and changing the carrier spacing, we can offer smaller channels, as you can see, from X16, but also a very small channel here, less than 1 megahertz width as a minimum. So the purpose of this is to provide some flexibility so that we can use this communication PHY on any media. So communication will be enable communication on power lines. Should it be AC power line or DC power lines? Coax cable, signals cable, but also optical fiber. So it can be used for optical fiber communication, using also light and radio wave. And one of the application I will explain next slide about radio wave. This is one of the reasons why we need to go into the very low frequency, because one of the applications of radio wave is to use radio wave underwater, to communication with drones and so on. And the propagation underwater is much better in lower frequencies. So this was one of the reasons to introduce this new channel in low frequencies. Of course, different conditions apply to different media. So it's not exactly the same using channels on the different media. And I take an example for power line. As I mentioned previously, frequencies are limited to 1 megahertz. And we also provide a notch capability for power control and mask for phase vector to reduce the unwanted emissions. So the conditions for using this new PHY on different media will be detailed into the standard. So one purpose of 1901c is to provide long-range communication, in particularly underwater using radio wave, but also long-range communication is very useful in smart buildings, smart city, and smart grid to increase the range and to adjust to meet the requirements for such infrastructure. So we have some illustration here about possible use case, and Miyake-san already presented. So you see the underwater IoT system that we can communicate with drones, AUVs, but also monitor camera, and also have some inspection machines for dams, for instance, and to communicate with them using 1901c and the specific channel on low frequencies. Here we have a building in that case, and we can use 1901 on the various different types of cable, including, of course, power line, but coax, but also control cables and solar, telephone lines, any kind of wires, we can use 1901. And 1901 is not limited to buildings. It can work also outside the building, connecting for smart city application, connecting the dwellings, the buildings, factories, and also connecting to the grid. For smart grid application, it includes management of the grid, but also metering applications. It will be detailed in next presentation. So how about long-range communication? This is to provide you an idea about how much we can extend the communication using a small frequency band. So on the left side, this is a simulation on the VCT cable, and you see that when we focus on the energy on the low frequencies and in the small frequency band, we can increase the range. we increase the range from 500 meters to 1 kilometer and 900 meters, which is a significant increase. For underwater, it's the same. If depending on the channels we use, we can have a communication from a very short distance, like 50 centimeters, or you can choose another channel and have more higher speed, but then the distance is reduced to 2 meters. Here is also another illustration about the flexibility and robustness provided by 1901c. So flexibility, because you can choose. Sometimes in some application you need more speed or you need more range. So you can select the appropriate channel according to the need. And on the left side, you see the correlation between the different channel and the carrier spacing and the throughput versus range. On the right side, this is more about flexibility, because in some building, power line topology is quite complex, and it's not necessarily the lower frequencies that are the best for communication. And 1901c will provide all the flexibility to select the best range in a particular condition, and to mix also a different frequency range. Okay, thank you very much. Again, should you have any further questions, do not hesitate to contact me.